Hey guys, I am going to share my screen and work out a problem from a homework question shared with me. It's homework 7-1, and it's on graphing parabolas or quadratic functions. And so that's when you have x squared. And so let's talk about one way of thinking about doing this. So it says we're given this function 3x squared minus 18x plus 23, and we want to turn it into this vertex form here. So I need to factor out what these two have in common. And so I'm just going to factor out from this 3 and the 18. I'm going to factor out a 3 because 3 goes into 3 and 3 goes into 18. So I have x squared minus 6x. I'm going to leave a space here because I'm going to need to complete the square, which I will explain in just a minute. So I'm trying to turn it into this form, which means I need something squared. So I want to turn this into something squared. And so to do that, you do something that's called completing the square. You take this middle term, you divide it by 2. So that would give us a -3. And then you square that guy, which would give us 9. And you add that 9 right here. But you're not allowed to just add random things in math. You always want to make sure that you didn't actually change the equation at all. So since I added 9, I need to subtract over here. Now here's the tricky thing. I didn't actually add 9. I added 3 times 9. I added 27, which means I need to take away 27 to keep the inequality, to keep the equality. So sorry about that. So we're going to now simplify this. So I made it so that this piece right here is x minus 3 squared, because it's whatever you got whenever you halved this middle term. We got that -3, that goes right here. And then simplify this part, 23 minus 27 gives us a -4. When you have a quadratic written in this format, you can easily identify the vertex. The vertex is h comma k. Okay, so that minus is part of the formula. So this, in this case, the vertex is going to be 3 comma -4. Okay. So there's the vertex. Another way to find the vertex is to have this trusty little equation. The vertex is -b over 2a, comma f of -b over 2a. So you can also do that. I can take -b, which would be positive 18, over 2 times a, which is this guy right here. And I get 18 over 6, which gives us 3. Then I would plug 3 into this function, and I would get the point that goes with that. Okay, so that's another way of figuring out the vertex. Now it says determine the x-intercepts. Now, anytime we want to find the x-intercepts, you let y equal 0 and solve for x. Okay, so I am going to let y be 0 and solve for x. So I'm going to plug in 0 for y, and then I'm going to try to isolate x. So in order to do that, we're going to add 4. We get 4 equals 3 times x minus 3 squared. I'm going to divide by 3. I'm going to then take the square root of both sides. Now, when you take the square root, you got plus and minus solution. So make sure you don't forget that. So I got x minus 3 on this side equals, on the other side, I have positive 2 over the square root of 3. And I also have x minus 3 equals negative, 2 over the square root of 3. Because the square root of 4 is 2. So then to solve this, I just need to add the 3 over. So we're just going to add 3. So it'll be 3 plus that and 3 minus that. Okay, so this is the x coordinate. You could also rationalize the denominator if sometimes they make you rationalize, which would be multiplying by √3 over √3. If I do that, I would get 3 minus 2 √3 over 3. And this one would be 3 plus 2 √3 over 3. You could also multiply the 3 by 3 over 3, and that would be 9 if you want to put the whole thing over 3. But these solutions were accepted. Just make sure when you write the x-intercept, you include both of them and you put comma 0, because the x-intercept, the y value is 0. And then the other one, 3 plus the square root, comma 0. Now to let the y, for y-intercepts is the opposite. For y-intercepts, you're going to let x equal 0. Okay, so I'm just going to plug in 0. right here. If we plug in 0, what do we get? Well, if I plug in 0, I would get 3 times 0 minus 3 squared minus 4. So 3 times negative 3 squared minus 4, so that's 9 times 3 is 27 minus 4 gives us 23. So that would be 0, 23. Then sketch the function. Okay, so I'm going to show you how to do that. If we go down here and sketch the function, so let me see. I wonder if it will let me redo that. I don't know now that I sketched it, if it's going to let me go back and do it again. So what you do is you plot, I'll just talk through it. So you plot the point. So the first thing I did is I plotted the vertex, which is 3, negative 4. Then you choose if it opens up or down. We're going to choose it opens up because the leading coefficient is positive. Then you need to plot a point. Okay, so when you go to plot the point, you look at this guy. This tells you how you're going to move. Now, normally a parabola goes like this. Over 1 from the vertex, up 1, because 1 squared is 1. Over 2, up 1, 2, 3, 4. Over 2, up 4, because 2 squared is 4. And then over 3, up 9. And it's symmetric, right? Now this guy is going to multiply, it's going to stretch those values up. So instead of going over 1, up 1, you go over 1, up 1, 2, 3. So that's what you need to care about here. You go over 1, up 1, 2, 3. So make sure you pick this as your second point. And again, we did 3 because we're multiplying it by this here, the scalar multiple, the leading coefficient. And so this is how you graph the parabola, making sure it opens at the right width. And then the last part is axis of symmetry, and that is just where does it get cut down the middle. Okay, so the axis of symmetry, let me see if it'll let me draw a line. This would be the axis of symmetry, which is x equals, it's an x equals line because it's a vertical line. It's x equals 1, 2, 3. So x equals 3 is your axis of symmetry. So let me see if it will let me type that in for you guys. X equals 3. Check. And then determine the minimum or maximum value. Okay, so if the parabola opens up, it has a minimum. If the parabola opens down, it has a maximum. And that is the same as the vertex. So this guy is going to be, it has a minimum. And so we can check that. And then what does it ask? The minimum value of G is. Now that's going to be how low it goes. So it's looking for the Y value. What is the minimum value? How low is this Y value? It is negative 4. So we're going to just type in negative 4. And then write the domain and range of the function. So the domain of parabolas is all real numbers. So it's going to be this guy, and it's going to be negative infinity to positive infinity. That's true for all parabolas. Now the range is from bottom to top. So if a parabola opens up like this, you're going to go, 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 go until you get to here. That's going to be the beginning of the range, and then it's going to go up towards infinity. If it opened down like this, like say it opened down and this point was negative 3 or something, then you would say from negative infinity to negative 3, including the negative 3. If you have something like this, say this was 2, then you would say this one starts at 2 and goes to infinity. So range is bottom to top. So for this guy, if we're looking at him, let's look back up. We know that it starts at negative 4 and it goes to infinity. So we're going to say negative 4 is included. And then infinity, for infinity, the bound, you always use open parentheses. Check that. Okay. So that is how you graph a parabola. Hopefully that was helpful for you guys.